Okay, Bismillah Rahman Rahim. So today is lecture number 1 of the course Irrigation Engineering. So today, first part of the lecture, we will discuss about the course outline. Now, the course aim, why we need to study this course. So the aim is to develop understanding among students towards water resources, hydraulic structures, and irrigation systems, salinity and water logging, and water management practices. So the basic purpose of this course is to develop the understanding related to water resources, what are different types of water resources. So as you have studied so far in the previous courses, especially in hydrology, that we have the rainfall which is coming down from the atmosphere to the surface of the earth, and then it appears as surface runoff or infiltrates into the ground surface and joins the aquifers. So we will study about the different resources of water and hydraulic structures. Since we have water flowing in the rivers, so we need to construct the dams, which for example you can see here. So you already know that dam is a multi-purpose hydraulic structure. We have river water that is variable throughout the year. So if we have enough quantity of water flowing in the river and the discharge remains uniform throughout the year, then we don't need to construct dams. So we just regulate the river flow by construction of dams. When we have high flows in the river, so we store that water, and during the low flows in the river, we release that water to meet the water demands. And those water demands can be domestic demand, industrial demand, irrigation demand, hydropower production. So these hydraulic structures that we are going to study, dams, we will study in detail. But beside that, we have other hydraulic structures that we have to study. For example, we take the water from the dam to the agriculture fields, farmlands. So we have to provide a network to carry the water from the source to the point where it is to be delivered to the crops in the fields. So for this purpose, we have to provide different hydraulic structures in the form of canal outlets. For example, we supply the water to the agricultural land. We need to measure the quantity also. Similarly, we have cross drainage works. For example, we carry the canal. As you can see here, canal, which is artificial channel that carries the water. So if this canal, it crosses a drain or for example a river, so then there are three possibilities. Either we have level mixing, that this water is allowed to mix with the river and then again it is withdrawn on the other side, or it is carried above the river, which is known as aqueduct, or it is carried below the river bed. In that case, it is known as siphon. Similarly, if we have the natural topography such that there is significant change in the slope, so then in that case we have to provide what is known as canal falls. For example, we have the drop structures. Let's say we have this is the natural surface level, and then there is a sudden change in the level. So then in that case we have to provide drop structures. Clear? So that we call as canal falls. So we have to study different hydraulic structures and irrigation systems. Now we have to supply the water to agricultural land. So there are different types of irrigation systems. You see here in this picture that we supply the water. You see here this is kind of furrow irrigation. You can see here narrow ditches, and the water is supplied. In the second picture you can see that we have what is known as a sprinkle irrigation system, in which you can see that the water is sprinkled over the crops. And in this picture you can see that we have a network of pipes where the water is directly provided to the roots of the crops. So you can see here that we have different types of irrigation systems. So we will learn that what are different types of irrigation systems and their efficiency in terms of supplying water to the crops. Similarly, we will study about the salinity and water logging. Salinity means the different salts which are present in the soil. One way is that when we supply the water, for example, you see here, so this water, not all 100% of water it is utilized by the crops. So this water it infiltrates into the soil and then it percolates through the soil profile. So it takes the salts if present in the soil at the surface. So it means that this water can also help in removing the salts which may not be beneficial for crops. This is one way of we can deal with salinity. But on the other side, if the water table is very high and the same salts can come up to the root zone and top of the soil and make it less productive. So we will study about this salinity and water logging. Water logging, when the water level, the groundwater level that raises to the surface of the ground, and eventually the land productivity that is adversely affected. The simple example is that when we constructed the Tarbela Dam, so in that case, because of the seepage of water, as you already know that Tarbela Dam is the largest earth and rock-filled dam in the world. There are different types of dams, but earth and rock-filled dam, the largest dam is Tarbela Dam in the world. So because of this dam construction, there is seepage of water, and as a result of that, the water table raised, and it adversely affected the land productivity. So this phenomena, this is known as water logging. So we will study what is salinity and water logging, what are the causes, and how to deal with such problems, and water management practices. So Water management practices means that how to increase the storage capacity of water for useful purposes. That is, we need to construct more dams in order to store the water and then use the same water for meeting different demands. Improving the infrastructure of these irrigation systems, which are in the form of weirs, barrages, canal outlets, cross drainage works, to improve its working and operation. Similarly, water management practices include how to produce more food with less water, how to better manage the surface water, and how to better manage the groundwater for make it more useful in meeting the water demands. So this is the course aim, to develop understanding among students towards water resources, hydraulic structures and irrigation systems, salinity and water logging, and water management practices. So we will study about all these in detail in this course. Now, course learning outcomes. CLOs, upon successful completion of this module, students will be able to define basics of irrigation and water resources engineering. So as we will cover different topics related to irrigation systems, the different hydraulic structures, the problems that we face in the form of salinity and water logging. So you should be able to define basics of irrigation and water resources engineering. The second CLO is to describe the different methods, principles, and processes involved in irrigation. So you should be able to describe the different methods, for example, of irrigation, as I show you here, these different methods of supplying water to crops. You should be able to describe them. The principles and processes involved in irrigation. For example, you see here, we have this canal. We should be able to describe the different theories that will be used to design these irrigation canals, the different processes involved in irrigation. So in this case, the different hydraulic structures that we have to study, as I explained, in the form of the dams, weirs, barrages, canal outlets, canal falls, cross drainage works. So you should be able to describe all these that involve in irrigation. And the third CLO is to apply the knowledge of irrigation engineering to solve basic and complex problems. So the basic knowledge that we gain in this course, we should be able to apply that knowledge in solving basic and complex problems. For example, if we have to develop an irrigation project, so you should be able to apply the knowledge gained through this course, how to plan, develop, and operate that irrigation project. And that would mean that you identify the source of water based on the crop water requirements, that we have to determine what sources are available. Is rainfall sufficient? If not, is surface water in rivers available? If that is not sufficient, can river water be supplemented with groundwater in that area? And then how to carry that water to that irrigation project to meet the crop water requirements and the infrastructure needed for successful operation of that irrigation project. So these are the CLOs, the course learning outcomes that we should be able to achieve after completion of this course. Similarly, these CLOs, then they are linked with the PLOs, program learning outcomes. So you can see here that these CLOs will contribute to PLO1 and PLO2. Teaching and learning activities. So course learning outcomes, the CLOs, that will be achieved through a combination of the following teaching strategies. There will be instructor lead presentations. There will be classroom discussions in the form of questions and answers. We will study different topics that will involve practical problems, numerical problems. So we will solve examples in the class to determine how to apply the theory. Then there will be quizzes to evaluate you how much you are learning from the instructor presentations and classroom discussions and examples that are solved in the class. There will be assignments, take-home assignments, where problems will be given to you for practice. Then there will be midterm examination, and we have end of the course final comprehensive examination. So these are the different strategies through which the course learning outcomes of this course that will be achieved. Now these program learning outcomes, which you must have good idea so far, these PLOs, the first one is engineering knowledge, which is linked here. You can see here PLO1 here and PLO1. So PLO1 is engineering knowledge. So an ability to apply knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. So you gain the knowledge. This is what it says. And PLO2 is problem analysis. An ability to identify, formulate research literature, and analyze complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences, and engineering sciences. So these PLOs are written in general terms because these are applicable to all areas of science and engineering. So the course learning outcomes that will be achieved, their contribution will go to this PLO1 and PLO2. As you already know that now in the OBE system, outcome-based education system, you will get actually two transcripts. One is the relative grading, and the second one is the transcript which will mention these CLOs and these PLOs. So the CLOs of this course, the percentages that will be obtained at the end of the course after all the assessment activities, they will contribute to these PLO 1 and 2. We have other PLOs also, for example, design development of solution, investigation, modern tool usage, engineer and society, environment and sustainability, ethics, individual and teamwork, communication, project management, and lifelong learning. So other courses, they will contribute to one or more of these PLOs. Now the course syllabus. So in the first part of this course, we are going to study introduction to water resources. So in this, we will study what are the different sources of water. So primarily, we have three main sources of water in the form of rain, and we have surface water and groundwater. So we will study about this in the context of Pakistan also, that what are the different water resources available for irrigation in Pakistan. After this, we are going to study irrigation. What is irrigation? What is irrigation engineering? What are the different methods of irrigation? Irrigation water requirement, how to measure that, irrigation water quality, and the different irrigation systems such as, for example, furrow, border, sprinkler, and trickle irrigation systems. So in the first part, we will study in general about the water resources and water resources availability in Pakistan. And then we will start with what is irrigation and the different methods of irrigation we will briefly discuss. Similarly, we will be briefly discussing this irrigation water requirement. For example, for different crops, how much water they need. Crop water requirements. So very briefly, we will discuss that. Similarly, the irrigation water quality, you already studied environmental engineering about the water quality. And these irrigation systems, so we will briefly explain. Now in Pakistan, we have the conventional irrigation methods that still are in use today, but in the developed countries, they are using sprinkler and trickle irrigation systems. You can see here, if I go back to here, you can see that these are the conventional methods. For example, free flooding. You just flood the agriculture area with water. So the problem here is that the water which is supplied, not all used by the crops. So consequently, the irrigation efficiency that is low means that you supply more water but less is used by the crops. So here we have enormous wastage of water here in the conventional methods. So we will study in Introduction to Water Resources that water, the freshwater resources, we do not have unlimited water resources. and also the distribution of water throughout in space and time, that is not constant. So in some parts of the world we have more water available, in some parts of the world less water available. So accordingly, then you have to manage the water to meet the demands. So in Pakistan, because we are blessed with glaciers in the north, and during the summer time the melting of glacier contributes to the flow in rivers. So that's why so far we are using the conventional methods of water supply for agricultural lands. But in developing countries where they are more cautious about the use of water, they are using the irrigation methods which are water efficient. For example, we just supply the water that are required by the plants. So in Pakistan, still it is not at greater level the use of these. For example, this is the sprinkler system. We are sprinkling the water over the area, or this system here, which is the drip or trickle irrigation system, a network of small pipes over the agriculture area, and we directly supply the water in the form of these drops, water drops, drip irrigation system. So the reason behind is that it is, although less efficient in terms of water usage, but it is more convenient. Convenient in the sense that we just flood the area with water. No maintenance, etc. required here, because you see here operation of these systems will require the cost of installation, then operation and maintenance. So this could be a reason, because of to operate also these systems you need the skilled labor. The farmers need to be trained. So this could be the reason why in Pakistan we are using conventional methods of irrigation. But anyhow, because of the water crisis which are looming around the world, we need to adopt more efficient irrigation systems. So this is what we are going to study in detail in this topic, Claire. Then we will study about canals. So as you already know that canal is artificial channel that supply the water, that carry the water. So we will study about the design of irrigation canals. We will design them, and as per your syllabus, we will apply the Kennedy and Lacey's theories to design the irrigation canals. We will also try to study about the irrigation canals, because you see the canals can be erodible and non-erodible. So we will try to cover both types. We will study about the canal lining, because the water that is carried in a canal can infiltrate into the earth, soil, so water is lost. So in order to prevent these losses of water, we can provide lining for canals. And for this we have to provide the material that is impervious to prevent loss of water. So we will study canal lining, what are its advantages and types. Also, maintenance of irrigation canals. Because when canals are constructed, so these carry water, and the water carry sediments or other debris or waste material, and these can get deposited in the bed of these canals and ultimately reduce the discharge carrying capacity of the canals. So this maintenance of canals for efficient water supply, this is very important. And you might have frequently heard in the news that especially in Punjab, the cleaning of irrigation canals, this is done every year to remove any waste materials that are deposited because they adversely affect the water carrying capacity. So we will study about maintenance of irrigation canals. Next, we will study diversion headworks. So how we divert the water from dams or rivers. So we will study about the canal headworks. There can be different types: storage headworks, diversion headworks. Storage in the form of the dams, diversion that we raise the water level and just divert the water, for example, weir and barrages. So we will study about the selection of their site and layout for the weirs and barrages. When we have canal headworks, what are their different components, the associated structures, and their functions? As I said that canals, they carry water, so water may carry sediments. So measures adopted to control the silt entry into canals. We will study how to control the silt entry into the canals, because the reason is that these silts that can deposit in the canal beds. So for this purpose, we will study silt ejectors and silt excluders. These are the measures that are adopted to control the silt entry into irrigation canals. We will study about different irrigation works. Here we have introduction to canal and regulators, how we regulate the flow into the canals, canal head regulators. We have different falls. As I said that if the natural topography is such that there is a fall in the slope, so at this point we have to provide what is known as canal falls. For example, you might have studied in hydraulics course about the chutes, drop structures. So we call them as canal falls. Flumes, we have open channel that carries water at or above the surface of the ground. Similarly, we will study about the canal outlets. These canal outlets are used to measure the discharge, the quantity of water, to control the flow of water to the agriculture fields. So these are known as canal outlets. And cross drainage works. As I said that if we have, let's say, this is the canal and the water is flowing in this canal and it has to cross a drain or river, So there can be three possibilities, that either we have level crossing, so this water can cross and then again the water is withdrawn on the other side. So this is known as level mixing. Or the other option is that this canal, it can be carried above the drain or river, in which case it is known as aqueduct. Or it can be carried below the drain, so that is known as siphon. So these are collectively known as cross drainage works. So actually these are small chapters: canal falls, canal outlets, cross drainage works. So we will study about the types and their functions, and monitoring of flows, telemetry system, how we monitor the flow of water. So you already studied. The simple example to understand is, for example, you studied the stream flows in your hydrology course. So we measure the discharge at different points along the river or stream. For that purpose, you studied the different methods. For example, you studied how to divide the cross section of the stream into different verticals, and then you use the mid section method, mean section method. You calculate the area and the velocity you calculate with the current meter. So if the depth is shallow, we calculate the average velocity at 0.6 times the depth of water, or the 2-point method where you use the 0.2 and 0.8 times the depth of water and then average. So you can develop the rating curve, which is the discharge versus the depth. Now we need to measure the stream flow every day for efficient monitoring. And the reason is that, for example, if from the level we know that what is the situation of water in the river, the discharge is reducing or the discharge has increased, or in case of floods, at least we know that what is the discharge at this point. That's why stream flow measurement is very important topic. So now to measure the discharge this way every day, it's very difficult. And if we have so many points along the stream or river, so what we do instead is that we can develop a rating curve that you studied in hydrology. That is the discharge versus the depth of water at a gauge section. So you just need to measure the depth of water, and you can use the different gauges, manual or automatic, and then you can use the rating curve to estimate the discharge at that point, that cross section. For that, we can also have telemetry systems, automatic systems. So the depth is recorded and then it is transmitted to the control room where the data is processed and stored. This is exactly similar to say that, for example, you measure the rainfall, so we have the rain gauge. So you collect the quantity of water and then you calculate the depth of rainfall. But for example, you studied the automatic gauge, rain gauges, for example, the tipping bucket gauge, where it can calculate the depth of water automatically. It can be stored or transmitted to the control room, which can be located away from the point of measurement. So we will study some introduction here, monitoring of flows. We will also study about the water logging and salinity. So as I already explained, we will study that what are the causes and effects of water logging and salinity, with special reference to Pakistan. So in Pakistan, as I already give you the example, in our province, After construction of the Tarbela Dam, the water table raised in the adjoining areas due to seepage of the water. So this contributed to waterlogging. When the productivity of the land is adversely affected by the high water table, this is known as waterlogging. And if the soil contains salts which are not beneficial for the crops, that is salinity. So we will discuss with reference to Pakistan what are the causes and effects, and how we can deal with these problems that we call as reclamation methods. Soil reclamation. You reclaim the soil or reclaim the land from these problems. So when we constructed the Tarbela Dam, the water table increased. It raised to the surface and it adversely affected the productivity of the land. So for that, we actually need to provide drainage network in order to drain that water to lower the water table and increase the productivity of the land. So we will study, you might have heard that in Mardan and Sawabi, you see we have scarp schemes. We have these scarp schemes. This means that salinity control and rehabilitation project. So the lands which were affected because of the dam, we store huge quantity of water and the seepage, and so because of this we have these scarp schemes. So we will study about them in detail and what we did in these projects to deal with these problems of waterlogging and salinity. And as you see that when we supply the water to the crops, not all of the water is used by the crops. So that is why for draining the water, we need to provide a drainage network in the irrigated areas so that the water drains, because we need the water at times. For example, when we feel thirsty, we drink water, but if you continue to drink water, it may have adverse effect on the health. So similarly for plants, when they need water at the right time and in right quantity, we should supply the water. Other than that, then it will have negative effects on the plant growth. So that is why drainage engineering is a subject in itself. So we will study some introduction about the drainage network in the irrigated areas. And then we will study about the dams. What are the different types of dams? The different forces acting on the dams. What is the criteria for site selection? So in this case, we will study the different types of dams and the forces acting on them, stability analysis. We will also study some introduction to the reservoir sedimentation and delta formation. The water which is stored in the reservoir carries sediments and then they are deposited, and ultimately the storage capacity that is affected. So these terms, these are related to the dams. We will study in detail because the water which is stored behind the dam can move in the form of waves. Clear? So it can apply some load on the dam, wave run up and set up. As I said, that dams on the one side have positive effects we store the water that can be used for different purposes: domestic and industrial water supply, irrigation water supply, hydropower production. Also, the stored water, if seepage takes place, then the groundwater aquifers are recharged. Similarly, when we have floods in the rivers, we can store the water in the dams and protect the downstream communities from the effects of floods. But on the other side, the dams also have the negative effects because we regulate the flow of rivers, so the natural ecosystems, they are affected. Also, you are storing the water, so it has impact on the environment. Water, when it stays in an area for some time, it can result into spread of diseases. So we will study introduction to environmental impacts of dams. So this is the course outline, the course syllabus that is given in the contents that are defined. These topics that are arranged in the weekly schedule. So this is how in each week we will cover these topics. So there will be 7 working weeks. Previously used to be 8 working weeks before the midterm examination and 8 working weeks after the midterm examination. But now we have 7 working weeks. After that we have the midterm, and then we have 8 working weeks before the final term exam, making a total of 15 working weeks. So we will try to cover these topics in detail. Assessment task activities. So we will have home assignments and quizzes. So that covers 20% of the 100% weightage. Since this is a 3 credit hour course, so there will be 3 in-class tests and 3 take-home assignments. So if online classes continue, then we can have online quizzes. And we have 20% weightage given to the midterm exam. So if we have physical exam, 1.5 hour written exam, and the final term, the weightage is 60%, and it is a 3 hours written exam, and it will cover the full course. That's why the percentage is more. So the final grading, that is relative. We have relative grading for this course, but remember the CLOs that you will score on the CLOs, course learning outcomes. So that is absolute, that is not relative. So you should know that minimum score on each CLO to pass, that is 40%. If any score on any CLO that is less than 40%, that CLO is failed. Even though you may have A minus, B plus grade, but it can happen that one of the CLOs or two may fail for you, because this is relative, clear? So we normalize your marks, but here there is no normalization. This is absolute. So you have to make sure that you perform well on each of the CLOs, the minimum pass percentage, that is 40%. Now the recommended books for this course. So we have this irrigation engineering and hydraulic structures by Garg. This is given in your syllabus. So this book is a big book covering every aspect of irrigation engineering and discuss in detail the different hydraulic structures. For hydraulic structures, the other book that is given in your syllabus, that is Hydraulic Structures by Moffett. So this book is not available in the library, but it is available online. You can download this book. Now, irrigation engineering and hydraulic structures, we have currently 54 copies of this book available in our library. Maybe you can download this book from different websites, but if you are interested in the hard copy, so we have 54 hard copies of this book in our departmental library. These are given in your syllabus. We have other books also that are very good. For example, we have Irrigation and Hydraulic Structures, Theory, Design and Practice by Dr. Iqbal Ali, a Pakistani writer, author. So he has written this book. It's available in the market also. If you are interested to keep a copy of this, you can purchase. And this is another book, Applied Irrigation Engineering. This is published from University of Agriculture, Faisalabad. This is in 2017. You can find the soft copy on the internet, or you can purchase from the market. It's very good book. The main idea here is that you will get some latest data about the water resources in Pakistan, the irrigation system clear. So you can get latest data from this book, published in 2017. Now this irrigation and hydraulic structures, theory, design and practice, we have 21 copies available in our library. So you can issue this book from the library. 21 copies are available. Another book, that is Irrigation and Water Power Engineering by Pumia and other authors. This is also a good book. Similarly, we have Irrigation and Drainage Engineering. This is also a latest book published by Springer, and you can download this from the internet. It's a very good book. This Irrigation and Water Power Engineering, we have 86 copies available in our library. Now another book which is also written by a Pakistani author, Iqtidar H. Siddiqui. So this is Irrigation and Drainage Engineering. This is also available in the market. You can buy. This is a good book, very comprehensively. All aspects of irrigation, all topics that are explained. So this is also a good book. And another book is Irrigation Engineering by Sharma. Now you can see here most of the books are either Indian or from Pakistani authors also. We have books, for example, this one, Irrigation and Drainage Engineering by authors from developed countries. But the reason here is that the latest books of irrigation, either we have the British or the US, they mainly talk about the emerging technologies in irrigation. as I already explained, the sprinkle and trickle irrigation systems. So because in Pakistan, even today we are using the traditional methods, the infrastructure remains the same with very little improvements or modifications, and the irrigation methods still remain conventional. So that is why in that context, uh, we need to follow these books. Clear? These are well suited when we compare the subject in the context of Pakistan.